Very good morning to one and all. Today we are discussing about the valve timing and port timing diagram. Wa- Now we are discussing about the four-stroke diesel engine valve timing diagram. This is the cut section model of four-stroke diesel engine. Let's see the various components. First one, this is a flywheel. So this flywheel. So next one, inside, so there is a piston, then connecting rod, crankshaft, and which is connected to the camshaft. So gear setup. So according to that, we have to change these valves. That is inlet valve. This one is exhaust valve. Okay. So we are doing experiment here. So valve opening closing time. So that is valve timing diagram. Here it shows the uh, various categories of valve timing. First one, inlet valve opening. Next one, inlet valve closing, exhaust valve opening, exhaust valve closing. So the positions for the from the dead center. So inlet valve opening is top dead center before. Next one, after BDC, exhaust valve close. Before BDC, exhaust valve open. After TDC, exhaust valve close. Very good morning. Today we are discussing about the two-stroke petrol engine port timing diagram. Okay, so two-stroke cut section model is there in our laboratory. So let's see how to measure the port. Before going to that, we have to know what is port. So three types of port is there in two-stroke engine. First one, suction stroke. Second one, transfer port. Then exhaust port. There are three ports. So inside we can able to see the piston movement. The piston will moves occurs. This is an flywheel rotation. Here some of the scale is there for measuring the angle, valve opening, port opening, closing angle. You can measure by this scale. See here in our laboratory there is no inlet port option. It will be cut it out. So this is the portion we have to give in for the inlet port. Now you see the holes to come. So there is a port is there. So that port we call it as here. Okay, so the some port opening is there from this bottom, from this pin. So the piston position is there. So this port is called as exhaust port. Then you see here, this is a transfer port. Some hole is there. So that port we call it as transfer port. So this is a three type of port: inlet port, outlet port, and a transfer port. Here the crank revolution is single revolution. First half suction compression is done. Second half power and exhaust is done. Pistons moves from top dead center to bottom dead center. Suction and compression process is done. Then bottom dead center to top dead center, compression and exhaust process is done. Okay, so we have to mark it as a reference here. Piston is top dead center. This is our reference. So 0, some reference. So we can to rotate this one. First one opening the transfer port. Okay, so it starts to open here at the bottom. The port is there. So that port. Okay, so fully open here. Just starts to open. We have to note it down the reading here. Okay, there's some reference reading 240. Then it further moves, the transfer port will start to open here at the bottom. Here you can able to see transfer port. So that angle you can able to measure here. So some reference line 210. Then further it moves, it reaches bottom dead center. After that it reaches again, come back to top dead center. The transfer port first close. You see, transfer port first close. You have to take this reading. Then exhaust port will close. Exhaust port will closed. Then it will be continuously working. So when exhaust port close, you have to measure the reading here. So let's see in table. You can able to see the port timing opening. So here only the two ports are there. First one, the exhaust port closing after bottom dead center. You have to measure the distance, or otherwise you can simply note it down the angle. So 60 degree around. Then the exhaust port opening before bottom dead center, you can able to mark the angle directly 65. Then transfer port closing after bottom dead center, it will be 57 degree. Transfer port opening 63 degree. Okay.